ToobTime illustrates and works with high voltage devices. Please do not attempt to work on high voltage radios, TVs, bench circuits, etc. unless you have been trained to work on circuits where you will be exposed to these high voltages. Please use your common sense, and if you don't know, ask for help. Hello, ToobTimers. Well, we're back. We're going to continue with the RCA Model 641 radio, and we're going to do our initial tests. This will be the first power-up. If you see text in red, that means that there's going to be high voltages dancing around your fingers, so you have to be very, very careful, using extra caution. So now let's get started. Let's take a look at the day's activities. We're going to check resistances. We're going to apply some AC. We'll plug in a rectifier tube. We'll do some measurements, and then we will de-energize it and plug in all the other tubes, and we'll see if anything happens. Okay, so the first thing we're going to do is check static resistances from the AC line, the high voltage windings, make sure there's resistance in the 6.3 volt heater winding, and then we're going to check for shorts to the casing or frame of the transformer. That would be a particularly dangerous situation because the frame might become hot. Anyways, let's get started. Okay, the first place we're going to start is the AC line input. So what I'm going to do is put a resistance measuring device. My ohm meter, as you can see, is right here. And I'm going to check for the resistance from the across the primary winding of the transformer. Okay, it's open. Are we concerned? No, because I have it turned off. We turn it on and we see 20 ohms across the transformer. Yeah, that's pretty good. That'll do the trick. So that looks safe. And then let's check our primary to transformer frame wiring. Make sure there's no shorts there. All right. Oh, there's still overload, which is in the ohm side. That means it's infinite. And on this one, we also see an infinite. That's good. So now what I'm going to do is connect one side of the ohm meter to the case, because the filament transformer and the high voltage windings are both connected to ground in some way or another. The high voltage winding is the center tap, and the low voltage winding, the 6.3 volt winding, goes from the one of the terminals through all the tubes in parallel to ground. So let's see. I have a schematic here, and my schematic shows that the plate is on pins 3 and 5. Now this is the rectifier tube. Here's the slot. Here's pin 1, 2, and 3. 143 ohms from one half of the high voltage winding to the center tap. The other one is pin 5. 3, 4, 5. And that's 154. That's okay. That's good. Now we'll check the filament resistance and see what happens. Okay, the filament on the rectifier is connected between 2 and 7. So here's pin 2. Uh-oh, half an ohm. And here's pin 7. Uh-oh. I would have liked to have seen some resistance there, not just a little bit of nothing. That could be a problem. It could mean that the 6.3 volt winding is in fact shorted to ground, or shorted together, I should say. Well, if that's the case, this will be a rather short video today, because what I'm going to have to do is unsolder those connections and then wire in a separate 6.3 volt supply, and perhaps a separate high voltage supply too, because if it's shorted out, I'm going to be tripping this little there's a reset device on my Variac here, and it's going to say, oh, nope, nothing doing today, you've overloaded the circuit. So let's plug this in, turn it off, and we will see what happens. Now what I'm going to do is take a little piece of insulation and stick it over the end of the probe tip, because then I won't have so much exposed metal when I'm measuring voltages. So let's go and see what happens. Now this is a variac, so we're going to ease up the voltage starting at 0% and take it up to 120 if we can. At the same time, we will give an occasional check to the high voltage plate supply and the 6.3 volts and see if that's coming up according to expectations. I'm a little concerned about the 6.3 volt winding though. I think perhaps putting these new caps in for replacement of the bumblebees may have been a bonehead idea. But okay, let's see what happens. We're going to take it up now to about 30 volts. So let's see what we have on the plates. On one of the plates, whoops, yeah, there we go. Let's see what happens. I almost did that. On one of the plates, we got nothing. On the other plate, we got nothing. Oh, that's not a good sign. 6 volts? Nothing. Nothing. Well, I'm a little concerned. Oh, I'm a little concerned. Let me turn it on first and see what happens. Yeah, I know. Blah, blah, blah. We'll go back to the same 30 volts. We'll check the plate. We have 75 volts there. And the other plate of the rectifier, we have 75 volts there. That's good. On the 6.3 volt winding, we have nothing and 2 volts. I guess we do have something there. Let's take her a little higher. What I'm going to do is hold it right on this, because it's reading 2 volts, and I'm going to run my variac up to 120 volts. I've got a little mark on my scale saying that I'm getting pretty close to it, so close enough for us kids at this point. Now, while we're doing this, we're going to listen for odd sounds and smells, because you never know what happens when you first power up a 70-year-old radio. Okay, 3.2 volts. That's halfway there. 3.5, 3.7, 3.9, 4, 4.5, 4.8. That looks pretty good. 5.8, 6.2, 6.25. That's close enough to 6.3 for right now. Now let's take a look at our plate voltages. One plate voltage is 219 volts, and the other plate voltage is 217 volts. I guess that's okay. So we have passed the first bunch of tests. Oh, I will also measure the frame, which I don't expect to see anything, but it's 0. Okay, so we've passed the AC application. We haven't heard any sounds. Haven't smelled anything. Nope. So now I'm going to de-energize it, turning it back down again. And I'm going to plug in the 6x5 regulator tube, and then we're going to, leaving all the other tubes unplugged, we're going to just put in the rectifier and see if we're getting a DC voltage. Now, the weirdness here is the electrolytic capacitor, which is down in there. If that thing is faulty, well, we'll certainly know in a hurry. But we'll charge on anyways. So I'll be right back, tube timers, and we will start going with the rectifier plugged in. Okay, tube timers, I'm back. I have plugged in the rectifier, and now I'm going to bring up the voltage on the unit once again to the rated voltage. I'm going to get 6.3 volts on the filament of the tube, because I know that's when we're at 120 volts when we get 6.3 volts out. So we turn it on, and we go up a little bit, a little more, a little more. Keep going. There's 6.3 right there. So now, maybe just a skosh higher. That's good. So now what I'm going to do is look for DC on the output of this regulator. Now the output of the rectifier, I mean. Now pin 8 is the output, and pin 8 sits on a pin 8 sits on a capacitor. This capacitor right in there. I don't know if you can see it or not. I have to go to full screen to see this inside chassis pretty well. So what we're going to do is go to pin 8. And is it really pin 8? Sure as heck. It's pin 8. Always check, and double check. So I'm looking at 283 volts of DC. So the rectifier is doing something. The filter capacitor looks like it's doing something. But what we're going to do is switch to AC and see how much ripple there is on the DC voltage, the B plus, at this point in time. Now there's no load, so I wouldn't expect a lot of ripple. 0.4 volts of ripple, that's nothing, peanuts. So that suggests that the rectifier circuit is working well. And now what we need to do is go and replace the rest of the tubes and see what happens. Now if you recall, when I took the tubes out of this device, I tested them all, and they were all garbage. So the 6X5 rectifier that I put in there was one I happened to have laying around in a pile of old tubes, happened to find one, and only one, and it was good, thank goodness. So now I'm going to find the rest of the tubes, and we're going to put them in and see what happens. Okay, tube timers, we're back. I've put in all the tubes. They're pretty good tubes. The 6V6 has a lot of heater to cathode leakage according to my tube tester, which may mean we have a hum in the speaker. That's okay for now. This is the iTube. It's bad. I put it in just to load the 6.3 volt circuit. But this is going to give us a second, an interesting sidetrack for our video here. It's building I have a 12 volt version of this tube, but this is a 6 volt tube. So I have a circuit that doubles the voltage to give us 12 volts from 6.3 and should work. I guess we'll see. Anyways, we'll have an opportunity to build it and see what happens. This little doodad is a socket extender. And in this case, one of the tubes is behind this coil here. And because it's behind the coil, I can't get at it safely with my probe. So I have one of these ancient Vidair adapt test sockets, and I'll be able to look at all the pins right across the top. And this is a 7 pin, so I can go 1 through 7. Okay, tube timers, let's get started yet again. Turn on our voltage. Set on the 6 volt line and start to crank her up. All right, we're not getting anything. Why aren't we getting anything? Well, that's not a good sign. That's not a good sign at all. Let's see, what have I done that I didn't know that I did? I'm not getting 6 volts out anymore. That's interesting. Sure as heck, not... Oh, DC, what a boob. I'm on AC. Of course I got nothing out. Okay, let's start it out over once again. Now we're cranking up very nicely. There we are, we have 6.3. We're going to start looking for B plus voltages around the circuit. Oh, listen to this. Well, that's some noise out of the thing. I'm turning the tuner a little bit. I don't expect to get an AM station. There's a little heterodyning. I'm tuning the knob to see if anything's going to happen. There's no antenna on this radio, so I don't expect to get anything, but you never know. Okay. That's not bad. We have something. I'll turn the volume down because we don't need to hear it. But what I'm going to do now is check against the schematic to see if the voltages are sort of right. I guess we have right voltages all over the place. We're going to start right with the pin 8 of the 6x5 rectifier, because that should be 251 volts. So pin 8. Well, we're not going to do, well, I'll leave it there anyways for a moment, because that's the ripple we have on our supply. 2 volts of ripple out of 251 volts. Well, that's good. We have 242 volts. We are expecting 251. That's well within 10%. It says the voltages are within plus minus 20% with a volt ohm meter. So that's pretty darn close. We'll check the volt. We'll go to the 6V6, which is this tube right here. And the 6V6 tube should have 203 volts on 4 and 259 on 3. So 3 and 4 are high voltages. Now let's see, where's 1, 2, 3. 232 volts when I wanted 239. And 204 volts when we wanted 203. Man, this thing's bang on. That's lucky. Of course, we haven't got any sound to come out of it yet that plays music, so far so good anyways. The 6SQ7 wants 86 volts on pin 6. Now, I'm not making these voltages up. I'm actually reading it off a schematic. Let me show you the schematic. Here's the schematic right here. So as I'm moving around, I am discerning the voltages. The eye tube is heated up, but it's dark. The eye is dark. There's nothing going on there. That's not terribly surprising. Okay, where was I at? We did the 6V6. We're going to go to pin 6 on 6SQ7, which is right next to this rectifier tube. 1, 2, 3, 4. And I'll do it again. 1, 2, 3, 4, 5, 6. Whoop. Little jumpy here. 82 volts, and I want to see 86. That's probably good enough. Now we're going to go over this tube, the 6SK7, and it wants to see 91 volts on pin 6 and 205 on pin 8. So we'll start with pin 8. $195 volts, and I wanted to see 203. Well, that's okay. And pin 6 is 91 volts. 1, 2, 3, 4, 5, 6. Come on, get on there. 97 volts. I suppose the 91. Oh, those are good voltages. Those are excellent voltages. So, we've powered up, we've tested. Let's review what we've done. Let me turn all this off first before I give myself a shock on the air. So what have we got here? To recap, This was the first power up of this radio. We checked our resistances. There's resistance on the AC line. High voltage winding was okay. 6.3 was 0 ohms. I really expected it to be a bit more than that. But it's just me, I guess. And there was no shorts to the transformer case. I plugged in the AC with only the rectifier. Oh, excuse me. I plugged in the AC and then I monitored the 6.3 volts and I monitored the output power transformer plate voltages. They were fine. I de-energized and plugged in the rectifier tube. I got a B+, which was good. Then I de-energized and plugged in all the other tubes, and I listened for sounds from the speaker. We heard them, you heard them, so I guess that's good. Turned up the volume and down the volume, and then we powered down, and now we can contemplate life. So, okay, tube timers, the next thing we're going to do is get an antenna on this and see if we can receive any stations, but that's part 5. Tube timers, I hope I hope this has been interesting to you, and I wish you all a good day and a good night.